Hello and welcome to another Math Monday. I'm so glad that you're here and you decided to join me today. I'd like to do more radicals. That's actually what I did in my last video, but I'm gonna go on a slight detour this week. So if you follow my Instagram stories, you saw me go on just, a little bit of a rant this week. There's an account for teachers that I follow that posted a video. So this video compared the box method of multiplication, which I'll show you today, with long multiplication, which so many people have been doing forever. And up until we wanted to change it, I've only ever heard complaints about it. And it was comparing them and basically saying that long multiplication is easier, quicker, faster, better. And the box method is stupid and takes a long time. As a math teacher and a mathematician, I find that insane. Because the box method of multiplication is probably one of the best methods I've ever seen. So when I started university, knowing that I was going to be a math teacher, I knew I was far too dependent on my calculator. So guess what I started to do? I stopped using my calculator. And basically what I ended up doing in my head was the box method. I didn't even know it was a method at the time. It was just an easier way of doing mental math. So why would we not teach that to students? The long multiplication method does not lend itself to mental math very well. So here's what I'm going to do. I'll show you the box method. If you don't love it, that's completely fine. But maybe be more open to new methods, because what works for you might not work for someone else. And therefore, we should learn multiple ways of multiplying so we can figure out which works best for you. Because the end result is the quickest way, the fastest way, the way that makes most sense to you. Why an answer is the answer to a multiplication question. So without further ado, here is the box method. So the box method of multiplication works best for 2-digit numbers. However, you can use it to multiply 3-digit numbers as well. But it's predicated on the fact that we're better at multiplying single-digit numbers or numbers that end in zeros, like 10, 20, 30, 40, 50, 60, and so on. So, for example, say I want to multiply 14 by 37. I'm going to break each of these 2-digit numbers into its 10s and 1s. 14 is 10 and 4. 37 is 30 and 7. So when I make this box, and I'm going to make it 2 by 2 since I have 10s and 1s in both numbers, on the top I'll put 10 and 4. On the side I'll put 30 and 7. So each of these boxes has a number by it, and all we need to do is multiply those numbers. So in this upper left box, what I need to do is multiply 30 and 10. That's 300. In the box to the right of it, I need to multiply 30 and 4. That's 120, because 3 times 4 is 12, so you add a 0 to the end. 7 times 10 is going to be the lower left box, which is 70, and then in the lower right box, we're going to multiply 7 and 4, which is 28. What I do with all these numbers now is I just add them together. So it's 300 plus 120 plus 70 plus 28. If you're teaching this to someone who's younger, just learning to multiply, they're probably pretty good at adding numbers at this point in a row, so you can write them out like that and add as you normally would. 3 zeros and an 8 is 8. 2 plus 7 plus 2 is 11, so you carry the 1. And 3 plus 1 plus 1 is 5. So there we go. The answer to 14 times 37 is 518. Of course, this took a little bit longer because I had to draw the box. I did all the extra little multiplication steps in there. I did the adding on paper, but hey adults, I'm pretty sure most of you in your head could go 300 plus 120 is 420 plus 70 is 490 plus 28 is 518. Right? Maybe the last one will take you a few extra seconds, but still, I think you can do that in your head. And if you can't, then maybe you need to practice your mental math a little bit more. So the main complaint about this method was it takes too long. Well, of course it takes too long when you're teaching it to somebody. Let's do one more example, just so I can show you how quick it can go by. Let's try 22 times 41. 22 is made up of 20 and 2, so I'll just go right to putting that on the top of the box. 41 is 40 and 1, so I'll put that on the side. And then again, I just fill in each box with a multiplication of the two numbers that reside by the box. So first one we have 40 times 20, which is 800. Then we have 40 times 2, which is 80. 20 times 1 is 20. And 2 times 1 is 2. Again, this one, you should be able to add all those in your head if you are above the age of, I don't know, 14. So 880 is 880. Plus 20, 900. Plus 2 is 902. Oh my goodness. But again, if you're teaching this to somebody who is below the age or the ability level of, say, grade 8 or grade 7, they can write this as repeated addition. That's fine. The more they do it though, the easier it'll get and the more that they won't have to do that on paper. So one of the reasons I love this method, other than the fact that this is actually just how mental math works for most people, is that it does lend itself to higher mathematics as well. I can actually transfer this over to algebra really easily by using the box method with polynomials. So one of the dreaded things you have to learn in grade 9 or 10 is multiplying polynomials. Specifically, we start with binomials by binomials. Those are just polynomials with two terms, hence the, prefix bi, bi. So for example, say I have x plus 2 times 3x minus 7. Most people are taught the FOIL method for this. FOIL means first, outside, inside, last. It's a fine way of memorizing how to multiply these things, but it's again just another arbitrary thing that helps us to remember to multiply everything. But then people get so used to the arbitrary rule and the arbitrary steps that they don't actually understand what's going on. So I can do the exact same thing here. X plus 2, I'll put that along the top of the box. 3x minus 7, I'll put that along the bottom. Just make sure the negative follows the 7. So this will give me a 2 by 2 box, and I just have to make sure I fill in all 4 squares by multiplying each component. 3x times x, that's 3x squared. Then we have 3x times 2, that's 6x. Then we have x times negative 7, that's negative 7x. And 2 times negative 7 is negative 14. Then we just add all these together. However, we can't add all these together because they're not all like terms. The 3x squared has to stay 3x squared. But we do have two like terms with the 6x and the negative 7x. That's 6x minus 7x, which is negative 1x. You don't have to write the 1. And then we have minus 14. None of those are like terms, so I just leave it like that. And it's just better than using FOIL because you can actually use it with more than just binomials by binomials. FOIL only works if you have two binomials. Anytime I've given a student a binomial by a trinomial without them doing the box method, they kind of lose their minds. They're like, what? We can't FOIL, what's going on? The box method, again, is something that can be really helpful here. So say I have 2x minus 5 times x squared plus 3x plus 9. So instead of a 2 by 2 box, I'll have a 3 by 2 box. Just because I have more room horizontally, I'm going to write the 3 term one on the top. That's the x squared plus 3x plus 9. And on the side, I'll write 2x minus 5. So here I have 6 boxes to fill in. Again, I just multiply the components. 2x times x squared, that's 2x cubed. 2x times 3x is 6x squared. 2x times 9, 18x. Negative 5 times x squared is negative 5x squared. Negative 5 times 3x is negative 15x. And negative 5 times 9 is negative 45. I can add all those together, add my like terms. 2x cubed, that's the only x cubed there, so I'll just rewrite it. Oh, 6x squared and negative 5x squared, those are like terms, so I'm going to add those together right now. 6 minus 5 is 1. So I'm going to write plus 1x squared, or just x squared. Another set of like terms, I have 18x and negative 15x. Those are both x to the power 1, so they're like terms. I can add them together and I'm left with 3x, so I'll add 3x. And then I still have a negative 45, so I'll minus 45 at the end. And that's how I multiply a binomial by a trinomial. All this to say, box method isn't so bad. Learning new things isn't so bad. I hope that you like this new method of multiplying. I'd encourage you to do it more often and see if you can do it in your head as an adult and not just take out your calculator all the time to do everything, because you don't need to. Keep that mind sharp. I'll see you next week.